Is that 37 degrees? I think so. Then, and that's your answer. Okay, that's the value of angle B here. It's 37 degrees. But here's like a little shorter way using this fact I just mentioned here. We know that these two angles add to 90, right? So if this is 53, this one's 90 minus 53, right? You can just go right away to that. And that's 37 degrees. So, you know, they're really essentially the same thing, right? But all I'm trying to say is if you have a right triangle, okay, and you know one of these angles, just go 90 minus that, and you'll automatically get the other angle. But if you want to do it the long way and go 180 minus 90 minus 53, and then you get 37, that's fine. Or if you want to do the other way, which is you go 90 plus 53. What is 90 plus 53? 143, right? And then you go 180 minus 143, and you're going to get 37 as well. And either way, you're going to get the right answer, okay? So basically what it comes down to is if I give you one angle of a right triangle, it's really easy to, one of the acute angles, it's really easy to find the other acute angle, okay? I think that's enough said on that. All right, let's keep going with our review of triangles. The last thing I'd like to review on triangles is another two special kinds of triangles, and those are isosceles triangles and equilateral triangles. Why don't I'm gonna write isosceles right here. I hope that's the way you spell it. Isosceles triangles. And over here, I'll talk about equilateral. And an isosceles triangle is a triangle which has two sides being the same length. So let me try to draw that for you. Oh, I'm just going to do it without that trick. Like that. That's not too bad. When two sides of a triangle are the same, we use this little technique of writing a tick there. You see these two ticks? Since they're the same tick, like we know that these sides are the same length. And you can, if you wanted to write two ticks, you could do that too, but make sure you write two ticks here too, because both being two ticks means they're the same length, okay? And the property of an isosceles triangle, if these two sides are the same length, then these two angles here are actually also the same. So one way to say what is an isosceles triangle, one way to say that is it's a triangle with two sides having the same length. Another way to say it is an isosceles triangle is a triangle with two angles measuring the same value. And when we have an isosceles triangle, like if two sides are the same, that forces these two angles to be the same. And vice versa, if you have a triangle with these two angles being the same, then necessarily these two sides have to be the same as well. Okay, and sometimes we call this the base of the isosceles triangle. These two sides are the same, and the remaining third side is called the base of the isosceles triangle. Okay, what's an equilateral triangle? Well, an equilateral triangle has all three sides being the same, right? An isosceles just has two sides being the same, but an equilateral triangle has all three sides being the same. So that's a little bit of a rough drawing, but it's not too bad. And let me write some ticks here. Okay, so I wrote one tick on every side, so that means all three sides are the same. I could have used double ticks like I did over here. Really doesn't matter. But if I want to use double ticks, I have to do a double tick on every side, because that shows that all three sides are the same. Maybe I should just write that here. Two sides have the same length. That's what an isosceles triangle is. And like I said, that forces these two angles to be the same as well. And an equilateral triangle is all three sides have the same length. And now here's a question for you. Since all three sides are the same in an equilateral triangle, that actually forces every angle to be equal as well. In an equilateral triangle, these three are all the same number. And that's enough information for you to tell me exactly what number it is, right? Do you believe me on that? If all three of these are the same, and they add up to 180, then what number must each of them be? Well, it's like 180 degrees divided by 3, right? That's 60 degrees. So that means each of these is 60. So an equilateral triangle is kind of special because we don't have any choice in what the angles are, right? Usually in triangles, the angles can be pretty much anything. But an equilateral triangle is so special that all the angles have to be 60. Okay, so I'm glad we talked about that, because you know how sometimes if you draw a height here, okay, if you draw this line that goes from here down to the bottom, you see how you get two right triangles? And this kind of thing is going to come up sometimes when you do trig. Same over here. We're not going to do trig on this triangle or on this one because they're not 90-degree triangles, right? They're not right triangles. But when I draw this height here, this line, then suddenly I get two right triangles, right? And then maybe I'll do trigonometry on those. And you'll see how that all works out later, okay? And I just want to mention one more thing about isosceles triangles before I have you do some problems by yourself, okay? So let's just get a new sheet. All right, the last thing I want to talk about in this little lecture is angles in isosceles triangles. At the very beginning, we talked about if we have a triangle and we know two of the angles, we can always find the third one by using the fact that all the angles add up to 180, right? But an isosceles triangle is a little bit special because if I know one angle of an isosceles triangle, I can find the other two. So that might not be something that you've seen before, but it's easy. So here are two isosceles triangles, okay? And I'm going to assume that this angle here is 70 degrees. We'll worry about this triangle later. Let's say that this is 70 degrees, okay? I claim that you have enough information to tell me both of these angles. And if these ticks weren't here, if it was just some arbitrary triangle, like if I just draw some arbitrary triangle here without really thinking, and I tell you this is 70 degrees, you have no clue about how to go about finding these two angles, okay? Without any other extra information, if I just tell you one angle of a triangle, you don't have enough information to find the other two. But an isosceles triangle is special, right? Because these two sides are the same. That tells us something pretty important, which is going to allow us to find both of these missing angles. So what is the key to get off the ground here? Well, just remember that these two sides being the same means these two angles are the same, okay? So if this is 70, this is also 70, isn't it? And now we go back to that usual property that all the angles add up to 180. So 70 and 70 is 140. And 180 minus 140 is 40. So we just found these two angles here with knowing only one of the angles. So we used the special property of an isosceles triangle there. What happens if I gave you this angle instead? Maybe this angle is 32 degrees, okay? How could I find the other two angles there? Well, let's think about that. This is a little bit different than the one over here, right? Because I can't, here I was given that this is 70, And automatically I said this one has to be 72. And then I found this one afterwards. But here, we know that these two angles are the same. We can't say that this is 32, right? This is not true. Maybe I should write, I'll write like this. So the double bars is a 32, and these single bars are the values of these two angles, which are the same. So how do I go about doing this one, which is just a little bit different than this one? Well, I know that this and this are the same, right? And I know that these all add up to 180. What I would do on this one, I'd first go 180, subtract 32, okay? And when we do that, we get 148. That's correct. And now we know that this plus this is 148. But we also know they're the same angle, don't we? So why don't we just do 148 divided by 2? And we get 74 degrees. So each of these has to be 74 degrees, okay? So this one's a little bit more, when I give you the angle at the very top, like opposite the base of the isosceles triangle, it's a little bit harder, right? Because you have to first subtract it off from 180 and then divide it in half. Whereas here, if this is 70, this is 70, and so this guy here is 180 minus 70 minus 70. But they're pretty much the same. So all I'm trying to get across here is that in usual problems, if I give you one angle of some arbitrary triangle and you don't know anything else about it, just knowing one angle of that triangle is not enough to find the other two angles, okay? Usually you need two angles of a triangle in order to find the missing one. But an isosceles triangle is special. If I just tell you one angle of an isosceles triangle, like either this one or this one, you're going to have enough information to find the other two angles. And that's a special property of an isosceles triangle. Okay, so that's all I wanted to say about reviewing triangles. We'll do some exercises now. I'll have you guys do some exercises now just to make sure you understand everything that I just talked about.